Okay, so let's suppose you wanted to solve this absolute value inequality. Now remember, on the test, I actually wanted to test with a worksheet. On the worksheet, you're going to get the absolute value by itself, right? Some of you forgot to do that. So on those of you that turned in the worksheet plus top theory, you got it back, but some of you still made a few errors with these. If it's a less than absolute value versus a greater than absolute value, those are two different statements. A less than is an AND statement. A greater than is an OR statement. Okay? So a less than is an AND statement. That's an AND right here. A greater than is an OR. With a greater than, there is no way ever you can write as a compound statement. A greater than must be written as two separate statements. You cannot write a greater than as one statement like you can here. See this right here, a less than? You can write it as a compound statement, and that's the way we did it. We said that the absolute value of 2x minus 1 is less than 5 means the same thing as saying 2x minus 1 is less than 5. And that and, I'm using the word and, right? And I said that. You can go back and listen. And I said, and at the same time, it must be what? Greater than a negative 5. Okay? You cannot do that with a greater than. Because when you write as a compound statement, and some of you tried, and some of you did this with this, and that means mathematically that's not correct. It doesn't make sense. So there is no way you can write a greater than as a compound statement. Whenever you write as a compound statement, that's an intersection. And is an intersection. Or is not an intersection. Or is a union. So remember when we did the intervals, we did the union? That's what that is. An or is a union. So with an absolute value less than, you can write it like this. With absolute value or greater than, you cannot. You write like this. You're going to say 2x minus 1 is greater than 5, or 2x minus 1 is what? Less than or equal to negative 5. Remember, you reverse all of this. That's how you write it. You solve each one. That's what you had to do. You had to write it as two separate statements. Those of you that wrote it as a single compound statement, mathematically that's not correct. Doesn't make any sense at all. Okay? Now, so over here you would add 1 to all parts. Those would be negative 4 is less than 2x is less than 6, right? So divide both sides by 2, all parts by 2 rather. I get negative 2 is less than x is less than 3. So that means all your solutions are between what? Negative 2 and 3. What that means is this, that x has to be less than 3, and at the same time, it has to be bigger than what? Negative 2. That's what an AND statement is. So when you graph it, here's negative 2, here's 3, you put parentheses, and you shade in everything between them. As an interval, you're going to say negative 2 comma 3 parentheses, right? Over here, for an OR statement, for greater than, you must separate it like this. You must separate it like this. Now, some of you, when you're separating them, you're not using the word. What word should you be using here? OR. Now, if you had written this, now let me say this. You could have written this as two statements. You would have said this. 2x minus 1 is less than 5, and at the same time, 2x minus 1 has to be what? Greater than what? Change the sign. Negative 5. And then you solve each one individually, and then you look at the intersection. So watch. Add 1. 2x is less than what? 6. Divide by 2. X is less than what? 3. Over here, add 1. 2x is greater than what? Divide by 2. X is greater than what? Negative 2. Remember, that's an AND statement. What that means is this. Listen carefully. Here's negative 2 and here's 3. Okay? This says that x This part here says that all my solutions can be less than 3, like this, right? And at the same time, they have to be what? Greater than -2. And then what do you look at? The part that overlaps. So your solutions are only between what? -2 and 3. So notice the difference between the two. That's why we do it this way. If you do it this way, it's easier. You see how much easier it is? It's more efficient than doing it this way? Yes. No, I have 2x minus 1 is less than 5. What you? Oh, no. No, I was saying that when I went this way, and I wanted to tell you that you could have written this as two statements as long as you put the word and. And means what? Intersection. And means intersection. Or means what? Union. Or means union. So when you did this, you add 1 to both sides. You get 2x is greater than 6, correct? Divide by 2, x is greater than what? 3. Over here, add 1. You get 2x is less than equal to -4. Divide by 2, x is less than equal to what? -2. Now the graph, let me do the graph here. So the graph, remember that's an R shape, so that's a union. So all you do is this. Here is -2, here's 3. This says a graph everything that's bigger than what? 3. This says a graph everything that's what? Less than equal to -2. And I don't look at intersection here. This R means what? Union. R means anything that's shaded is a solution. So anything that's shaded, right? So that's your answer. So that's your graph. So as an interval, you would say -infinity, comma, -2, union, and then bracket 3, comma, infinity. Okay? Now, for those of you that wrote it as a compound statement, make sure you understand why it's not true. So for your worksheet, did any of you? There's someone in here that did that. Who did it? Jasmine, let me see what yours says so I can tell everybody why you can't do that. All right. So this is what Jasmine has here. Okay, see how she wrote it? She has, this is greater than, she wrote it as a compound statement, right? Remember, a compound statement, you only use it if it's an and statement. A greater than is a what? An or statement. Now, here's what you're saying. Now, remember when we talked about this, where we said that when you write a compound statement, what you're saying is that x is less than 3, and at the same time, it's what? Greater than -2. Okay? All right. Let's see if that makes any sense. She says x must be greater than or equal to 1/2, and at the same time, it must be less than or equal to -2. Give me a number that's bigger than 1/2, and at the same time, less than -2. There isn't any. Well, she's saying there is. These are the solutions. But according to this, there isn't any. All right? This does not follow this. According to this, there should be no solution. You understand? So an absolute value greater than can never, ever, ever be written as a what? Compound statement. That only a compound statement can only be written if it's what kind of absolute value? Inequality. Less than. Because this, according to this, there's no solution. Yes. Yeah, but remember what we said. You had to do what first? Divide by. Yeah. Oh, the reason why she had it wrong, though, yes. So right here, it is true that now she did divide by -2. She did that correct, but she kind of skipped a step, and then she kind of messed up because if she had done that step, which meant that she should have written this, right? Oops, for it. You'll agree? She see nowhere in here did she write it. So that's a less than. But see what she did? We talked about that. Your inequalities, they'll be pointing in different directions. They should be pointing in the what? The same direction. So this should have been 3x minus 2 is less than 4, and at the same time, it must be greater than what? Negative 4. Same direction. She has it pointing in different directions. You skipped a step. We did flip it. Greater than becomes what? Less than. You missed a step. If you had done this step, that's not this. You should have written this, girl. You should have done that. Next time, don't skip that step. All right.
Thank you.
Okay. Well, thank you for letting us use yours.
Thank you, Jasmine.
Now, see, Jasmine is not going to make that mistake on the test. All right. So that's what I want to mention about the inequalities. Some mistakes that some of you are making.